So now let's look at the second example for the Maclaurin series. Find the first four terms, again the first four terms of Maclaurin series for the function of 1 over. So our function in this question is fx is equals to square root of 1 plus 2x. Or I can write in the form of 1 plus 2x power of 1 over 2. Use the result, give the first four terms of the Maclaurin series for this one. Square root of 1 plus 2x squared. So the difference here is now we have 2x squared. Hence, approximate this function from 0 to 1 correct to 5 decimal places. Like I mentioned before, fx in Maclaurin series, we substitute 0. First, the function, substitute 0. Differentiate the function, substitute 0. Differentiate again, second derivative, substitute 0. And the third derivative, substitute the value of 0. The first part here is all the same. So this is the function, and this is the series, Maclaurin series. We just substitute this value. So here comes the second part. How about this one? If this function, square root of 1 plus 2x, we get this function. So if here is x, so here we x, x, x. Now when come to this part, we have the x squared. So what we now do here is, from this x, now we need to change to x squared. Here is x, the yellow part is x. So from this x, we change to x squared. Why we have x the squared here? This is because in our first function, we have the squared here. And then finally, this x, we change with x squared. Where come from the x cube? So this cube means that it's this one. Here we have the cube. That's why here we have the cube. And then we simplify. So integration of this square root also equals to the integration of this part. So integration this part. So after integration, substitute the value. And then we will get the answer. If you look at this exercise 5. Find the Maclaurin series of fx as 5 is the term x cubed. Hence, differentiate, integrate this part. So here, be careful. Here is x cubed, whereas here is x. So what we do here now, let's say, I will show you. So first, the function of fx is equals to 1 over 3 minus x. Or I can write in the form of 3 minus x power of negative 1, because after this I want to differentiate. So first substitute the 0. So here I get 1 over 3 minus 0. So here is 1 over 3. And then I differentiate f prime x. So first I differentiate the index. Second I differentiate the bracket. When I start to differentiate, multiply the index to the front minus 1. So here comes, I get negative 1 in the bracket, 3 minus x power of negative 2. Then I differentiate the bracket. Differentiate 3, I get 0. Differentiate negative x, I get negative 1. So negative 1 times negative 1 is positive 1. 3 minus x power of negative 2. Or I can write in the form of 1 over 3 minus x squared. Substitute the value of 0, f prime 0. So 1 over 3 minus 0 squared. 1 over 3 squared. This is 1 over 9. Okay, right. Second derivative. First, differentiate the index. Second, differentiate the bracket. Multiply the index to the front, minus 1. Negative 2 times 1 is negative 2. 3 minus x power of negative 3. Integrate, differentiate the bracket. 0 minus 1. So again, negative 2 times negative 1 is positive 2. And then 3 minus x power of negative 3. Or I can write in the form of 2 over 3 minus x power of 3. Substitute the value of 0. So here come 2 over 3 minus 0 cube. So here is 2 over 3 power of 3. 2 over 27. Finally, the third derivative. Again, first differentiate the index, second differentiate the bracket. Multiply to the front, minus 1. So I have negative 3 times 2, negative 6. 3 minus x, power of negative 4, times differentiate 3 is 0. Differentiate negative x is negative 1. So negative 6 times negative 1 is positive 6. 3 minus x, power of negative 4, or in the form of 6 over 3 minus x, power of 4. Again, substitute the value of 0. I should get 6 over 3 minus 0, power 4. So 6 over 3 power 4, where 3 power 4 is 81. 6 over 81 will be 2 over 27. Before that, this is not 34. This is 3 power of 4. So 3 power 4 is 81. 6 over 81 is 2 over 27. So here come the Maclaurin series. So what is the Maclaurin series? Here is fx is equals to f0 plus f prime 0. Sorry. So here is, let's say again, f0. So fx is equals to f0 plus f prime 0 over 1 prime x plus f double prime 0 over 2 factorial x squared plus f triple prime 0 over 3 factorial times x cubed. So now I start to substitute the value, where this fx is 1 over 3 minus x. f0 is 1 over 3. So 1 over 3 plus f prime 0, 1 over 9. Over 1 factorial is 1 times x plus f double prime 0 is 2 over 27. 2 over 27 divided by 2. And then x cubed. 2 because 2 factorial. Plus f triple prime is 2 over 27. 2 over 27 divided by 6. 3 factorial is 6. X cubed. I try to simplify this part. 1 over 3 minus x is equals to 1 over x plus 1 over 9 over 1 is 1 over 9 x plus this part I should have 2 over 27 actually is divided by 2 is 1 over 27 x cubed here 2 over 27. Oh, this 2 value is 2 over 27. Let's check again for this part. So negative 3. So negative 2. Sorry for this part. Let's see negative 2 here. Do I get the same value here? So 2 against this is negative 2 times 1. Let me check first for this one. Here is negative 3 power of negative minus 1. Sorry, this part, -3. Oh, sorry, this part is here. So from here, multiply to the front, I get this one, -3. Okay, -1. So -1. This is this part. -3 times 2, -6, -4. Yes. Okay, right. I think it's correct. So this one, 2/27, divide by 6. So 1/81 x cubed. So here is the function for 1/3 minus x. This is the first part of the answer for the first part. Hence, estimate for this one. So before I try to integrate this part, so what I have to do is I need to find 1/3 minus. Now x squared is changed to x cubed. So what will happen here? So here is 1/3 plus 1/9. This x we change to x cubed. That's why I put a bracket x cubed. Pay close attention for this one. 1/27 against this x, I change to x cubed. But don't forget, here is x squared. Sorry about that. Here is suppose it's x squared. It's not x cubed. X squared. Please change to x squared here. Sorry for this part. So here suppose is x squared, not x cubed. So here we have x squared plus 1/81 x cubed. For this x against, I change to x cubed. And then don't forget this one is power of 3. So here we have the power of 3. So we try to simplify. 1/3 minus x cubed. Here is what is equals 1/3 plus 1/9 x cubed plus 1/27 x cubed. 3 times 2, 6, x power 6 plus 1/81 x power 3 times 3 is 9. Then we integrate. Let's say I use a green color. This one. Integration for the function of 0 to 1, for the function of 1/3 minus x cubed with respect to x also equals to the integration from 0 to 1 for this function, which is 1/3 plus 1/9 x cubed plus 1/27 x power of 6 plus 1/81 x power of 9 with respect to x. Now we start to integrate. Integrate 1/3 is 1/3 x plus 1/9. Integrate x cubed is x power 4 over 4 plus 1/27. X power 6 will become x power 7 over 7. This is integrate plus 1/81. So x power of 10 over 10. So from 0 to 1. So I just try to simplify. Here I get 1/3x plus x power 4 over 36 plus x power of 7 over 27 times 7 is 189. And finally, x power of 10 over 810 from 0 to 1. So substitute the value of 1 here, first minus and then 0. So means that 1/3 times 1 plus 1 power 4 over 36 plus 1 power of 7 over 189 plus 1 power of 10 over 810 minus substitute 0. For this one, when I substitute 0, this part is 0. So here comes the answer. 1 over 3 plus 1 over 36 plus 1 over 189 plus 1 over 810. So the answer, 3 decimal places. For 3 decimal places, I should get 0.368. So here is the exercise 5. We try to compare with the answer. Let's say exercise 5, 0.368. Yeah, the answer is correct. So this part. So what you need to pay attention here is from this part, this is actually the same. First, the fx, substitute the 0, differentiate, substitute 0, differentiate, substitute and 0. This is the Maclaurin series. Only now, this part is how to change to x cubed. What we get here is 1 over 3 minus x. Whereas the question request for the second part is 1 over 3 minus x cubed. So kat sini x ni kita tukar dengan x cube, ingat. X cube kuasa 2 kat sini. X tukar jadi x cube, sini ada kuasa 3. And then you try to simplify again. And then we integrate. Integrate this function. Also like integrate this part. So kita integrate kat sini lah. Lepas integrate, ganti nilai, kita akan dapat jawapan. So this is Maclaurin series.